Hello everyone, my name is Subhashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solution and I welcome you all to this special webinar. Today's topic is configuring and troubleshooting the EIGRP, the Enhanced Interior Gateway Routing Protocol that we have for enterprise networks in the Cisco environment. So let's discuss the features of the EIGRP. What are the unique features of EIGRP that makes it so special? So let's begin. So what are the EIGRP basics? What is EIGRP after all? It is an enhanced interior gateway routing protocol that we know, and it is a dynamic routing protocol as the RIP, the Routing Information Protocol, or the OSPF. EIGRP is a Cisco proprietary routing protocol. Now it is open standard, but for a long time it was a Cisco proprietary protocol, means it can be configured only on the Cisco routers. It couldn't be configured on other routers, say Juniper. Nowadays, you can configure it. Now, that facilitates communication between routers within an autonomous system because there is a concept known as ACE, autonomous system in the EIGRP, like it is a logical bounded area, and inside that area, all the routers reside and they communicate with each other. EIGRP converges quickly and it utilizes a distance vector routing protocol that includes link state characteristics, means it's a hybrid protocol, or we call it an advanced distance vector protocol. Like it has some features like the link state protocol, like link state protocol maintains a topology table, and also it has a distance vector routing protocol that it has a hop count limit. So it is like the RIP in that case because it is limited to the hop count, but it has some link state characteristics as well. So it is an advanced distance vector routing protocol. Now, in case of EIGRP operation, the EIGRP operates through a neighbor discovery process, and its algorithm is dual. That is a diffusing update algorithm, and it is used to establish neighbor relationships, and it sends updates and utilizes a dual to calculate the best path for the routing. So, if there are multiple paths, then it uses to choose the best path through the dual algorithm. Now, what are the EIGRP metrics? EIGRP uses several metrics including bandwidth, delay, reliability, load, and MTU. Now these are the K5 metrics, but it uses mainly the bandwidth, and in some case it can use delay also because it has a composite metric, bandwidth and delay, but by default bandwidth and lowest bandwidth, not the highest. These metrics can be configured to influence the routing decision and to do the traffic engineering, so the path selection. These metrics can be manipulated. So what are the configuration steps of the EIGRP? To configure EIGRP, you can start by enabling the protocol on the router with the command router EIGRP, and then you have to provide the ACE number, the autonomous system number. It should be same in all the routers. It cannot be different because it is not like the process ID in case of OSPF. It is the ACE number. All the routers in the same ACE. Now you have to define the networks to be included in the EIGRP process using the network statement. So you have to give the network command and you have to give the networks of the local interface, the directly connected interface of the router. Then interface configuration, you have to configure EIGRP on specific interfaces using the IP EIGRP and ACE number command. This you can also do like the IP OSPF. We can go to the specific interface and we can give the command IP OSPF and the let's say the process ID. So in this case also you can do the IP EIGRP and ACE number. That is an alternate approach, and this allows for more granular control over which interfaces participate in EIGRP. So for that interface you can only give this command, not the entire network. What are the verification commands? Now use commands such as show IP EIGRP neighbors and show IP EIGRP topology, so to verify EIGRP operations. So if you give show IP EIGRP neighbors, it will actually show you the neighbor relationships, neighbor statistics, and topology, it will show you the entire topology and ensure the correct functioning of the routing process. What are the optimization techniques for EIGRP? First is stub routing. Now, stub routing is a technique used to reduce the size of the EIGRP routing table by preventing certain routes from being advertised to specific routers. Like if one neighbor router has failed one interface is down. So what will happen? It will send the query to all the upstream neighbor routers. And this way the traffic will increase. So we can actually minimize that query process by using stub routing. That is a feature of the EIGRP. Now, it is particularly useful in branch offices where internet access is centralized, ensuring that routers only know about routes to the hub and reducing unnecessary traffic. So, unnecessary traffic or too much traffic is not needed between the spokes. Only the hub is the central point, and everybody should be connected to the hub. So, that way you can implement the stub routing there. Then the route summarization, that is another technique. Route summarization condenses or it summarizes multiple network routes into a single summary address. Now, thus reducing the number of routes advertised in the EIGRP routing table. This can lead to improved performance and faster convergence times by actually minimizing the size of the routing updates. Then load balancing. EIGRP supports unequal cost load balancing, allowing traffic to be distributed across multiple paths that have different cost. Like it is not like the OSPF because OSPF actually does the equal cost load balancing. So it distributes load among the equal cost paths, but not in the case of EIGRP, it can do unequal cost load balancing. By configuring the variance, there is a feature called variance. EIGRP can use paths that are not only equal, but also those that are less than a specified multiple of the lowest cost route. So there is a thing known as the RD, relative distance. So, and the reported distance that is. So, and the AD, the advertised distance. So you have to use the variance features wisely so that all the paths to be qualified as a valid path because there is a FD, that is visible distance. Reported distance is reported by the neighbor, and the FD is the lowest cost path, that is the best path. So any other path should be within the FD limit. So you have to use a variance feature, a variance multiplier, so that other paths can also fall inside that range. So that is a unique feature of EIGRP, that is the unequal cost balancing feature. Then troubleshooting the EIGRP, common issues arise as typical EIGRP issues include misconfigured interfaces, or say the IP address is misconfigured, it is shut down, lack of neighbor relationship, and incorrect EIGRP AS number. If you have given the AS number is incorrect, like you have changed the AS number, so definitely the neighbor relationship will not come up. Identify these issues often involves reviewing configuration and examining the route tables. Now, debugging tools like EIGRP provides debugging tools such as debug EIGRP packets and debug EIGRP neighbors to diagnose the problem. So you have to debug the problem and you have to sort out the outcome of that. These commands enable you to see EIGRP messages in real time, and it helping to identify where failures are occurring in the routing process. So you have to do the debugging to identify the root cause. Now, root cause analysis, like conduct root cause analysis by systematically checking configurations, monitoring the traffic flow, and using EIGRP commands to trace routing decisions. And it helps to pinpoint the source of routing discrepancies effectively. So, what are the best practices that can be considered? When designing EIGRP networks, consider factors such as what will be the network size, what will be the topology and redundancy also. Now, properly segmenting networks like the network segmentation and implementing EIGRP in a hierarchical manner also can enhance overall performance and manageability. Then the scalability means that carefully planning the EIGRP implementation is crucial for scalability. Techniques like route summarization, using stub routers that I talk to you, and setting appropriate maximum path limit for the load balancing help ensure that EIGRP can grow with the network. Now, to implement security measures, implement EIGRP authentication to secure routing updates and prevent unauthorized routes from joining the EIGRP domain. Now, you can do the EIGRP authentication just like the OSPF, and using MD5 authentication adds a layer of security by ensuring only trusted routers can exchange routing information. Now, we can conclude that in EIGRP, it is definitely a robust routing protocol, as you know, and for a long time, it was a Cisco proprietary protocol. That was the biggest disadvantage of the EIGRP had, but now it is open standard, so anybody could use it. And in those days, RIP was the only option, routing information protocol, and the hop count limit was very small, 15. So EIGP, in that case, it was a savior in case of the routing protocol. So EIGP had a too much, can say, the popularity among the administrators. So that is about the EIGP features in theory. And I can also do the configuration of the EIGRP here. So in the packet tracer, you can configure EIGRP. Pass it on it. Give the IP. EIGRP supports the classless routing also, but you can give classful also. Classful and classless both supported. Give clock rate to the DC. And go to config mode and give router EIGRP and this process number 1, that is autonomous system number, and network 10.0.0.0. And you can give the wildcard mask, but it is not mandatory. This is the serial network. So this is the autonomous system number you have. Go to the other router. Go to also the serial interface. Where EIGRP in the process, say the S number should be same, and say the network statement 000, and add the serial, and right away you get the adjacency. It has found the new neighbor. So if you give show IP root, it is not showing. If you say show IP root EIGRP, is not showing either, because this Ethernet port is not connected. That is one of the troubleshooting. You can see that it is not connected to any PC. So you have to definitely connect. Go to the PC. So give the IP 10.0.02, default gateway 10.0.0.1. and now it is verify. See, the first net zero has come up. Show IP root, and now you can see the EIGRP root. This is noted as the D for the dual algorithm. Also, you can give the EIGRP after the show IP root to view only the EIGRP root, not the connected roots. So here you can see the EIGRP roots are being seen, and show IP EIGRP neighbors. You can also see that the neighbor details are here shown. Also show IP EIGRP interfaces. If you see that the interface that is participating in the EIGRP process number 1, that is the ACE number actually, is the serial and fastest code of this router. Also, the show IP EIGRP topology table also you can view. There's a topology table where you have this P for passive and A for active, means that A means active means that the recalculation is happening for the feasible distance or the successor route. Now that is not happening because already the successor is chosen. That is why it is passive. If the EIGRP chooses one new successor, then it shows as the active. So there is a topology. So there are a lot of things, and also the EIGRP traffic also you can see. So traffic means that how many hellos sent or received, updates sent or received, queries, replies. So all these messages you can see, acknowledgements, so all this, and all these query messages you can see, and the replies also you can see. That's the EIGRP traffic. So a lot of things are there in the EIGRP because EIGRP is a very well known protocol for Cisco, and it's been quite there for quite a long time, and definitely it is having a major role in configuring the enterprise networks, because in ICE backbone we do not use the EIGRP, RIP or OSPF, and we use only BGP and ISIS, but for enterprise networks EIGRP is a very stable protocol. And this EIGRP is a main topic for the Cisco CCNP Enterprise. You have a lot of things in the EIGRP. It is not a part of Cisco CCNA 200301 anymore, but it was there before, and hopefully it will be there also in the future. But if it is not there, still you have to know some basic stuffs like EIGRP like this. Otherwise, it will be difficult for you in the examination with Cisco CCN as well. So this was about the basic EIGRP, and also we have discussed the EIGRP metrics, the different calculations, the features of the EIGRP. That is very important for your knowledge on networking, Cisco networking as a whole. And I think it would be very helpful for your studies for CCNA 200301 and for CCNP Enterprise. Take care and keep studying.